Welcome to CO2 Mondays and the Refrigeration Mentor Podcast. I am so excited. I'm here at the Arneg Canada factory where they're building a ton of CO2 equipment. It's unbelievable, the project this team is working on. Such a great team. I'm super excited. I'm having a returning guest who has been on the podcast on the CO2 Mondays multiple times, bringing huge value to the CO2 world industry by sharing his immense amount of knowledge on CO2 and willing to have and come back on the show. Phillip, how you doing, brother?
Trevor, always a pleasure, buddy.
Awesome. Well, Phil, why don't you do an introduction of yourself for the new people watching, as well as a bit about Arneg Canada?
Absolutely. So I'm Phillip Walker, Director of Refrigerant Solutions for Arneg Systems, which is part of Arneg Canada. We manufacture everything from electrical panels to metal racks to large-scale industrial CO2 machines to small little 10 kilowatt CO2 machines. And what you're seeing right behind us right now is one of the skids that are currently on our shop floor. It's a large 125 kilowatt industrial machine.
Awesome, awesome. So this is just one of the pieces of CO2 equipment you've built, because you guys built many so far. So why don't we talk about some of the equipment that you are working on and that you already have in the field?
Absolutely. So our biggest target market right now, as much as it's fun to build big, we've been building a lot of small. Been doing 10, 15 kilowatt C-store designs, and then a lot of larger, right up to 1.7 megawatt designs for warehouses. So everything in between we've been building lately, but there's been a huge demand for that C-store marketplace that we're really happy about.
Awesome. And so you have a few installs already. And,
absolutely.
You know, CO2 is not new. We've talked about this week over week, almost a year I've been doing these, and CO2 is not new to the industry, but the new technologies that are coming is newer. You know what I mean? The new designs that you guys are building, all this is evolutionary to the CO2 industry. Let's talk a little bit about some of those C-store projects that you did, some of the R&D that had to go in, the things that you learned in it, and where you're at with the C-stores now.
So the C-stores was a different concept completely. Here we have a large-scale industrial, heavy, very intense CO2 design. C-store, we had to bring that package and simplify it immensely. The C-store design we have right now currently only has one high pressure electronic valve, only one electronic valve that we're currently working. We're using a Danfoss ICS for the flash gas side, and we're really hoping to mature that through R&D to remove a lot of those troublesome components that C-store type technicians are currently working on in the field.
Yeah, that's amazing, because when I think of CO2, I think of lots of electronics, lots of wiring, lots of programming, but you're telling me one electronic valve in this whole system.
In the whole system, and now with some of the evolutions from some of the suppliers in the industry going forward with CO2 thermostatic expansion valves, it's helped reduce some of the case controller requirements. So we're really banking on this and following that trail right now, and we can simplify the machines, easier to sell, easier to train on, and bring it into a very small C-store format.
Yeah, and what I like about that, when I was at Chilventa back in October, I was with my good friend Patrick Clarity from Danfoss, and he showed me that TXV or thermostatic expansion valve, and I'm pretty excited about it because that's going to really help reduce some of the costs on equipment, reduce some of, I guess, the troubleshooting side of it, because a lot of people know TXVs. It's been around for decades and decades, and so it's going to really help with that transition for a lot of technicians out there.
Yeah, and we've been trying to really entertain that marketplace for that type of refrigeration technician that services C-stores. And what we saw is this huge spectrum of technicians. And we did our research, trying to simplify the equipment was not only resourceful for the technician, but for the store owner. You're looking at a lot of these store owners have only worked with plugins.
Yeah.
And now they're moving from a plug-in to a mini CO2 booster. So bringing it more into those simplified CO2 thermostatic expansion valves, eliminating electronics, a lot of the complications that they feel they would have to deal with, we eliminate that problem right away.
Yeah, and so I know we've talked many times about the amount of R&D and a lot of the work your team here. You've got a skilled team here. Like I've been talking to, all of them have different tickets, refrigeration tickets, electrical engineering tickets. Let's talk a little bit about your team here and why you feel the quality here. And we're going to see some of the quality. Like he's been showing me some cool stuff on the stainless side. Out of this world, but why don't you talk about the team?
So this is a real big pride of Arneg. So all the guys in the shop are licensed. They're all provincially registered. This is very important to us, and not only in terms of quality, but in terms of overall comradeship between the guys on the shop floor, especially between engineering and technician, but as well as ownership. Because we have to give our employees empowerment to be able to feel that they can build the machine how they feel is required as well for a service technician. And even though most of our brainchilds begin with the customer, end up on my desk and Jonathan's desk, our engineering team and our quality control team and our technicians on the shop floor are completely empowered to take that design, challenge us, and to fine tune it to ensure that the final product is going to meet the needs of the customer.
Yeah, and it was so exciting just to meet the team here because they take a lot of pride in their work and they really want to bring a top quality product to the technicians out there, to the contractors out there. So super excited to see more of the stuff. So let's dive into it now. So we're here to talk about oil management, and we've talked about it many times, and you taught me a lot on different oil management. Let's talk about the different oil management strategies before we get into this one that are out there.
Yeah, well, I can speak for Arneg. I know there's a few different philosophies out there, but we use two principal designs. We use on-demand or continuous flow. So on-demand is when the oil reservoir is full, we have a photo eye, she gives the demand a signal, we open up a valve, and we feed oil in through the lines. Continuous is a constant flow. There is no photo eye on the temp right or on any type of oil separator. She's flowing continuously. Smaller machines, we typically do a high pressure, continuous oil flow design. We'll select the compressors that can adequately handle the high pressure oil flow, and we do not depressurize the flash tank, or excuse me, the oil reservoir into the flash tank. Larger machines or more oil flow or applications such as this, where we have certain parts of the skid that are pumped out throughout different times of the year, we go on demand. So we can easily isolate the circuits and then for serviceability, and we can leave them idle throughout like a winter month application.
And so the big thing is the capacity. Is that why you'll do these two different circuits, the size of the system?
Yeah, absolutely. So if this application behind us right now is a mix between refrigeration and HVAC. It's a HVAC flooded system.
Wow.
We got about 1 million BTUs going out. We're going to use free cooling throughout the winter months. So we got about a good 6 months that the HVAC application isn't even going to be running. So we gotta properly pump that system out and leave it in idle. We're going to go through a few things that we've learned today on how we achieve that and how we don't get any type of return gas migrating back into the oil separators, which is a common little phenomenon that occurs with CO2.
Yeah, that is super exciting. So let's just start from the start. So your compressors start up and they start to run and they start to move CO2, high pressure gas. They come along and they come into the oil separator. What's the next step?
Well, in this application, we're going to if we have heat reclaim, we're going to go through a heat reclaim, but the end result's always the same. We're going to go into a manifold, and that manifold is going to go out into the gas cooler. We're going to come back from the gas cooler. We're either going to do some flash gas subcooling, or afterwards, we'll go through a high pressure expansion device and go into a flash tank. This application here is slightly different because we have an intermediate vessel to maintain a certain column of liquid that we need for a flooded evaporator. But the principle always remains the same. And even in a basic supermarket application, our principle is always to have independent groups. So you can isolate 50% of the rack and leave the other 50% running. So if I'm coming to do my service, I can isolate this temp right, change my oil filter, do my oil test, change my Swedge Lock oil filter here in the back, but yet my 50% of my other rack is still moving.
Yeah, we're just going to move this up so we can take a better look at that.
So a recipe that we associate well with is having the ability never to shut down the entire rack to change an oil filter. So regardless if it's supermarket, industrial, we will always have independent oil separator groups. And it's just appropriately breaking up the compressors, because even in a supermarket application, we're not going to have all compressors running throughout winter. We're going to have some idle applications. So by breaking up the different oil separators, it allows us to do service. It allows us to pump out a suction group. It allows a great deal of flexibility in the overall design.
Yeah. So in this design, I see here that you have 1, 2, 3, 4, and I notice the one further over there that we'll look at afterward, it's larger than the other 3. Why is that?
That's right, because that suction group, that's at the very end of the refrigeration, and we have the major horsepower associated with that. So this application, when we designed it with the customer, throughout winter months, we could see as low as 25% load. So that being said, we're only going to run with a quarter of that load, and that larger mass group is going to sit idle throughout the winter.
Okay, yeah, and that makes so much sense, because you'll need something a little bit bigger than this in that
That's right.
in that time of year.
You got it. And then breaking up your oil groups as well, or your suction groups, allows us to work with a smaller pipe. So we get away of sometimes, we do a lot of socket weld, as you can see back here. It gets away from the larger pipe. We really work a lot with 1 1/4, as you can see here, or 1 inch or 3/4 lines that you can see hit.
Yeah.
A lot easier for us to install and manage.
Yeah, and we'll take a good view of the wells. Like, these are some of the best stainless steel wells that I've seen in the industry. I've seen a lot of equipment already out there, but your team is doing a great job. So we separated here. Then we have a little eye right here. So what's this eye actually doing?
Yeah, so let's go through some of our recipes that we're willing to share with everyone in the field. And this is an area that we've done a lot of research on. So if I'm going to pump out suction groups, I got to put a check valve here. You'll notice all Arneg machines is going to have a check valve on the outlet of the oil separator.
Yeah. So
this is for the reason, if this machine goes off and sits idle, gas can migrate back and condense while the machine is off, or while the suction group is off, inside the temporary oil separator.
So that would actually fill up?
That's right. Wow. And then when we start the machine up, we're going to create thermal shock inside the oil separator, which could cause significant problems to the machine.
Yeah.
So cold startups are never favorable. So we put the check valve here. It helps migrate that. Check valves also creates a bit of a back pressure. These are Refrigeration 0.3 bar check valves.
Oh, nice.
And it helps equalize the various differential pressures in the system. So all our machines that any of you guys will ever work on, you're going to notice that there's check valves on all outlets of the temporary oil separator.
Yeah.
And in terms of isolation, you're always going to have your purge valves, ball valves down the line. On the manifold line for the compressors, you have a ball valve. So it's as simple as isolating your line, purging it, and then being able to open up your oil separator and changing your filter.
And we've talked about this time and time again, is that you need to have the piping schematic or the PNID to know where all those specific valves are to isolate it properly, because you got to do this safely, and you can't do it safely if you don't know where all the valves are, right?
Yeah.
And so manufacturers like Arneg give so much great information to help you as a technician out there to understand how to do this properly. So I love that. I love that.
So let's get into how she's working right here. So in terms of oil management, fairly straightforward. What we have here, these are our pressure reliefs. I know some of the folks maybe from different areas of the world tuning in right now. This may not be a requirement, but we run 3/4 inch Schedule 10 stainless steel. We need to run this up to the roof. We have a lesser, it's a type of the manufacturer, a lesser pressure relief at 1740 by CSA. We're required to do this. All the rest of the piping in the machine is Schedule 40. Okay. So we have our supply line coming in here. This is an on-demand. So the first step that you're going to see is we got a Cree 1 photo optic eye here. As the oil reservoir, as the gas passes through, a reservoir is going to begin to fill with oil. A continuous demand for oil will not have this photo eye. You just have a sight glass here. The specific design sends a signal back to the controller, and then the controller opens up a block solenoid, now allowing that to bleed the oil from the oil separator.
Because this is not a storage vessel. We're not trying to store oil.
We're not trying to store oil in this. We have a separate oil reservoir for the project. So this, and then I think that's important to know. Coming from the 920s of the world for temp, we get that question quite a bit. You know, I came from a HFO or HFC project. I was typically using a reservoir. These aren't oil reservoirs, and they weren't designed for it. Oil reservoirs do exist in the world for CO2, but this specific application, we need an independent reservoir for this application. So if you have oil coming up here, it wasn't intended to do so. And if these see high pressure, meaning high spikes, you could see damaging to the gasket and the oil rings inside. So proper oil management, proper relieving pressure by depressurization, the oil reservoir into the flash tank is critical for this type of application.
No, and that's so important, because yes, this is an oil system. We call it an oil management system, but there's an electrical component to it as well. So just because you're understanding the oil management side of it, you want to understand the electrical side, because this here is going to send a signal, like you said, back to that controller to be like, okay, let's open that solenoid. And so this is when understanding the sequence of operation is so important of your system.
You got her. And it's all reliant on this. So common havoc in the field. If you go and you're filling up with oil, start by taking a look at your optic eye. Is your optic eye calling? Or we're going to get down to the line here. Is your check valve not opening properly?
Yeah.
So as this calls for oil, essentially what we're doing is we've created a huge pressure differential. We're going to siphon oil. We're going to suck oil into our oil reservoir. We have a dedicated shut-off valve here.
Yeah.
So this allows, we get a lot of questions for oil tests. You can literally isolate your oil reservoir, turn off your suction group obviously, close it off, and then you got your drain line right here.
Yeah. Relieve some pressure first.
Relieve some pressure first.
Definitely relieve some pressure first, because there's a lot of, could be up to 1200, 1300 PSI, but relieve that. But this is how easy it is to take an oil sample. And oil samples are so important, because you need to be checking that to see the quality of the oil, because I've seen this time and time again. When I used to work at Copeland, compressor would come back and you would see the copper plating all over. This is POE oil, but it needs to be changed because you can get dirt in it. These are big applications and a lot of different people work on it. You could get copper, filings, moisture, so it's really important to take oil samples.
Yeah, and a good rule of thumb is after startup, you give it a good 72 hours. We should be changing oil, or 1 week at the most. Most manufacturers are going to cover that first oil change, so it's essential that it's done. Another thing to think of is everything coming here downstream is going to wind up in your compressor.
Yeah.
So the filters in here are not made to filter out the minuscule microns. They're made as a general filter. You need to think of our additional particular filters prior to your compressors. So this is what we have here. Going downstream, and I'm hoping everyone can see this.
Yeah, they can see it.
This is not a ball valve. We get questions quite a bit on this. Is this a ball valve? It's not a ball valve. It's actually a swedge lock 40 micron filter. Okay. At startup, we ship a 15 micron with it, get all the particular debris out, and then after startup, we'll put a 40 micron in. And this helps remove, this is the first stop to removing a lot of that debris that's filtering through the system just because of all the work that was done on the system. This is common debris that's going to circulate, right? Another interesting thing is a lot of the times we'll take the head off and we'll clean the inside of the oil separator. If you take a good look, just not the filter, but after the startup, you could have some debris inside here that needs to be removed as well. Leaving this type of debris in here is not is future problematic, because it could stop the photo eye from properly sensing the oil level, okay? And another thing to check here is when you do your first oil change, see if your sight glass, you screw them right off. It's not going to let out any pressure or whatnot. You have a sealed sight glass inside here. Ensure that your sight glass is clear. If she gets muddied up, it's just like the same with your oil regulators. You get the sensing area filled with debris or any type of callus that's going to create an insulator. You're not going to read the oil level properly, okay? And if it's dirty, she could be sensing then all the time, so it's continuously dumping oil, okay? So very simple things just to check with the first oil change.
Tip. That is a great tip. And because like Phil said, it goes this way. We got this filter right here, then the check valve, and then that goes into an I believe you guys are using OMCs, maybe?
Yeah. So all the compressors here are using OMCs. We like the dual sight glass. It's rated for 1,800 pounds pressure. For the Copeland application, we've had a high amount of success with it. So it's working quite well. And on this specific rack, it's all Copeland compressors.
Yeah, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
We got 10 large semis on this, absolutely.
Beautiful, nice.
So, and following then, the trail of oil, it's really that simple. So whether your application, whatever this is hooked up to, she's going to read. Some other units in the field, like our counterparts in Europe, do a same type of oil demand, but instead of a photo eye here, you could actually see a minute board. And it's kind of like a bunch of dip switches, and it comes on and off depending on the amount of seconds you set it for, right? So it removes an additional electronic piece for the control system.
Okay,
and we've seen that. We're actually doing testing on that right now at a few applications with Copeland to see how that works currently now.
That sounds super cool.
It's very interesting, So we feed oil out. Remember, here's your oil drain line. isolation valve for your oil,
Yep.
swedge lock strainer. You're going to have another filter downstream when we hit the K65 or the type K copper over here, depending on the type of application we're building. We're probably going to have a 303T, Sporlan 303T, or an Emerson AODF to remove any last bit of oil particulate matter prior to hitting the crankcase.
Yeah.
It is essential that we keep the crankcase and the oil regulators free of debris. I can't stress that more than enough.
Yeah.
Probably some of the biggest oil issues when we did our testing we saw were oil alarms from the oil regulators. You lose an oil regulator, you lose a compressor.
100%, yeah.
So it's just a little measures that we can put into place. And then once a year, you're changing a 40 micron filter.
Yep.
Standard machine doesn't have 4. This is industrial.
Yeah.
Very, very, the approach to this machine is they do not want downtime. So on-site maintenance is possible. We took all measures possible to ensure that oil feed to the compressors was adequate for the customer.
Yeah.
Right?
No, and that is super interesting, right? Because every customer is going to have a different request. And this is one cool thing about Arneg. You customize your CO2 systems for your customers.
Yeah, we're able to do that. This specific machine wasn't our brainchild. We can't take credit for this. This came from the customer who has an excellent in-depth knowledge on CO2 and an excellent engineering team. And they came to us on this project and we kind of followed their coattails and what they felt was an optimal machine for their customer.
Yeah.
And then we threw it to engineering and it just developed in this project right now. So not only were we humbled enough to learn a substantial amount of what we could achieve with some of their ideas, but we're able to produce a quality product for the customer. Right?
No, I'm like a kid in a candy store here. There's so many cool things. I think we should move around to the other side and take a look at that.
So continuing where we left off, guys, this is your oil line.
Yeah.
Coming from, if you remember, we had a drain line at the very end, shut off, swedge lock, filter, after that check valve. Here's that oil line. We got 4 oil separators, we got 4 block solenoids. These are high pressure Danfoss block solenoids. This is something we really enjoy using. We've had no failure rate to date with these types of solenoids from Danfoss.
Wow, it's interesting.
So these are managed by your photo eye. So your photo eye sends a signal to your controller that we got to drain oil. The block solenoid opens, and now we're going to bleed oil through into the manifold and into this oil receiver. Now, it's important, how do we keep this flowing? Yeah. Well, we depressurize the oil reservoir into the flash tank. Okay. So it is a constant depressurization. When this block solenoid opens, and then we have a good pressure differential between oil reservoir and flash tank that we feed.
Okay, so I've heard lots of people say so many different things out there. Oh, you need 150 PSI differential, you need this. But what is it? Like, can I do 60 differential, 70 differential? Does it have to be? Or, you know what I mean? There's so many different things out there.
I think everyone's looking for a magic number. I got to be honest, there's no magic number. We do HVAC applications where we have a differential, maybe 40.
40, wow. And did you hear that? HVAC applications. So CO2, if you're out there, you're working in HVAC world, commercial HVAC, you got to start learning about CO2 because it's already here.
Yeah.
Yeah.
But between between suction side here and our flash tank and here, we're going to have about 130 probably PSI differential to keep that moving. So as soon as that block solenoid opens, she's going to start to move. And this is critical. We get a lot of questions on this. Yeah. This is a very simple, I mean, us as refrigeration technicians, we've been working with this type of stuff for a long, long time. It's just being applied differently, right? So these are, needle valves. And basically, I can close it all my way down. Yeah. You know, my oil gas mixture is going to come in. She's going to drop down in the bottom. She's fully closed. Nothing's going to move. Yeah. This is not a depressurization valve. And that's really important. This is a metering device so I don't flood my oil receiver. So cool. So I have the ability at the very end to flood my manifold. If my manifold is full, then I'm going to feed oil into my oil receiver. And the missing part here, which is we're still building the machine, we have a sight glass right here.
Yeah.
So we can see if the manifold's full because I want a full sight glass of oil.
Yeah.
Then we have a sight glass on our copper line prior to going out to the compressors.
It's so cool.
It's as simple as we're going to, when we start this machine up, we're going to ship them closed. We're going to do it a full turn, and we're going to give it a half turn afterwards.
Wow.
To start up. And we're going to do all our valves that way as a startup. We're going to start one circuit at a time because we're not going to bring them all on at once.
That makes sense.
And we're going to watch how we feed through our oil sight glass. Okay? And then we have the ability right now to properly adjust my oil flow.
That is so cool, because now one thing that you really need to understand, we're working on the oil system here. All this is connected back to a microthermal controller, or it could be an E3 controller, depending on this one's a microthermal, really good electrical wiring in these ones that are pretty awesome what you guys are doing. But you want to go back and understand all those pressures like Phil's talking about. What's your oil pressure, what's your flash tank pressure, what's your suction pressure, and then really start to think about what's happening inside here when one of these block solenoids open. That is key. You want to understand each component. When this opens, it's going to change the pressure somewhere else, right? And so understanding how that works is key, that sequence of operations.
Absolutely. And if you ever have to work on your own, say you got a leak from your sight glasses right here, you can treat these as a ball valve as well.
Yeah.
You can shut them all off. You got your ball valve right here, so then you have full accessibility to work on your manifold or work on your line right here, or to change your sight glass, right?
That is so cool.
And we can do all this without ever putting any gauges on, or we can do this all through the control system. On the supply and return lines of the temp rights, we have pressure transducers, so we can measure the pressure differential. Some of the oil separators come with a pressure differential thermometer that shows us, hey, basically, what is the pressure differential change the filter? We do that right in the controller. We can set up a fairly simple application that says, hey, if we're at this amount of PSI pressure differential, pretty simple. Let's send out a notice. We should start thinking about changing that filter, right?
So that's so great, because I've seen that time and time again where there's a blown filter in there for months and people don't recognize it and they just keep adding oil and adding oil.
Well,
and adding oil.
Filters are going to blow, I believe, when we get around 60, 65 pound pressure differential, right? Yeah. And by all means, we shouldn't be getting there.
No.
And a blown filter is not only problematic for the filter debris inside, but we're likely going to mess up our oil feed in the situation, right? So, and then we're going to have little bits of filter get stuck all in those little swedge locks down here, all in these little valves. And if it does circulate in the system, it could go elsewhere in our sealed system. And getting them out elsewhere with little screens is very, very difficult, right?
And what I really like is like how neat this is put together, how symmetrical. Like you guys spend a lot of time doing this, like making sure, look how nice this looks. Like it looks so easy to work on, and there's space and you can move. I know the more compact system's a little bit different, but man, this looks really awesome.
Well, the layout here and the ability to put tools in place was the specific request of the customer. The customer indeed is someone that's going to be maintaining this equipment for the next 25 years. So they came to us and they said, you know, I want to be able to do such and such with a certain area, and we respected that. Absolutely.
Nice.
Absolutely. So this is key right here. You know, we get this quite often, is how is this depressurizing? There's nothing you should really be concerned of. It's going to do it naturally. But any type of system that depressurizes in the flash tank, when we spoke about flash tank management, if you recall, we got to be conscientious as we change flash tank pressure. We could offset how our other components within the system are working. So putting flash tank pressure higher to remove flash gas, let's be conscientious on what is depressurizing into the flash tank and how are we using that flash tank to substitute some other means in the system like flash gas subcooling, flash gas to heat suction vapor on a very low temperature racks. So making simple set points in a controller is easy to do, but it could cause complications elsewhere.
And definitely go check out that YouTube video that me and Phil did on flash tank stability. I learned so much on that, and it was just amazing. So that one there's, check that podcast out for sure. What else can you talk about on the oil system?
Well, so all oil reservoirs are going to have, at least in Canada, we do all our oil reservoirs with a separate relief.
Okay.
So as you see here, there's no, this is the depressurization, and it's intentional that the guys do it this way, because on a oil relief, or on this pressure relief line, we can't put any ball valves. So when you come up to your oil receiver, just a common look at, you can say, hey, I got a ball valve on here. It's located right here. This is definitely my depressurization line.
Yeah.
This has to be my pressure relief line, right? Because I cannot obstruct my relief line. Yeah, so that's a simple way with any Arneg rack you can make the difference. Okay.
Yeah, no, it looks really, really cool.
So oil receivers for us come in all shapes and sizes. We're doing one right now with a 60 liter. This one's a 29 liter. We go as small as 7 liters, or even high pressure designs, small minis. You won't even have a oil reservoir. You could have a piece of 3/4 inch stainless steel pipe with a continuous feed.
Wow.
At high pressure.
Wow, yeah, that's pretty cool.
Yeah, but moving towards that, oil flows much easier because the pressure differential is so great. Make sure the type of compressors you're working with can handle a high pressure oil design. Like working with maybe some Copeland scrolls may not be the best application for a low temperature, high pressure oil design due to the limitations. Yep.
Yeah, no, that is so cool. And I just like how clean it's done. The wells are amazing. Like that is an art in itself. And this is another thing that you're going to start to see more and more of, depending on where you're at in the world, because I know in Europe there's a lot of K65 and high pressure copper. Even in the US you're using a lot of that. But here in Canada it's different. The field piping on the high side needs to be stainless steel, right? So this is where a lot of people are like, well, how do I do it? What do I do? Well, you got local welders. A lot of the contractors, especially here in Quebec, they got a team even in Ontario. They got guys that do this now and are getting better and better at it. And but this is an art, like that is some of the best wells I've ever seen.
So in terms of working with stainless steel, once you get familiar with that, we have a preference stainless steel over high pressure iron copper alloy. We work considerably faster with Schedule 40 than we do with K65.
Yeah.
K65 to heat and bend is problematic. We have to be very careful on the stresses we put on the pipe. But Schedule 40, I mean, you can see it. She's going to go together. We take good care of it. If we have to insulate it,
this for a second. I'm just going to
we never want to put arm flex, standard arm flex.
Check some of these wells out. Like, look at that. Now that's an art.
So this is called, and maybe it's another potential episode. Chris could talk about it, but this is a 2-pass weld. So what we do is we first start up here, and we pass all the way around, and then we start down here, and we pass the opposite way around.
Wow. Yeah, that is impressive.
Yeah, we were very fortunate. Some good friends of us who do natural gas rigs and whatnot came in and spent 3 months at Arneg way back when and really took into heart on how we should weld. And once again, all our guys are provincially and certified, right? And so everyone has their papers at Arneg. Everyone's gone through the provincial testing, right? We're audited on a regular basis. So yeah, it's extremely important for us that our machines arrive at the job site leak-free, high quality. Absolutely.
I love that. And I just like the way this is laid out, like the compressors, the way you can replace the compressors on here. I've seen some where it's very difficult to replace a compressor on a CO2 rack, and I've seen a few designed. But this here, you guys got a really cool design and way to drop out the compressors without having to cut anything.
Well, yeah, so the last thing we want to do is, if a service technician is working on the job site, the last thing we want them to do is cut anything out. It's just so problematic. If you see what the oil separators are from our engineering team, we can put all these underneath our arm and walk away with them, So that's something the guys always consider. Heavier components, we're going to move them closer to the edge of the rack so we can tip and get them out. Lighter components, we'll move them more inside. Compressors, if we want to take a look. So these Copeland compressors, this is a mix of, we got 11s, 15s, 20s, and 29 horsepowers on the specific rack. But if we need to change a compressor, we got our service valves. We got a stainless steel service valve here, and this is really important. We have a ball valve in the back on our manifold line, which is we can talk about at another time, but we can isolate our compressor here. We can take our discharge service valve off, and she's going to hold in place. We got 2 blocks down here. We got a heavy steel block and then a heavy rubber grommet underneath here. You want to take these bolts out, and they're still loose right now because they're not set. We want to knock these out. You can tap them out. Compressor's going to fall about 2.5 inches. You knock out your bolts in the back, take off your service valve, she slides right out.
Wow. Yeah.
You should not have, you're going to move your box out of the way, but you should not have to cut your stainless steel pipe.
Oh, I love that.
And you can see how we've supported it. We've supported it exactly for that reason, is on here on the side, that as you slide your compressor out, your total sub-manifold, as we call it, or our stainless steel assembly for the compressor remains in place.
That is so cool, because that's one of the biggest things I see technicians worrying about is like, what happens if a compressor fail? How do I take it out? Like, do I have to move something or cut something? And this makes it so easy.
Yeah, we've done several tests with our members in the field and our team ourselves on changing compressors with Copeland. And this recipe has worked very well. We've tested as well for all their manufacturers. The same type of recipe works for Bitzer or Dorin or whoever we install for the project.
Oh, I love it. I love it.
Just another note of something some of you guys may see that's different. These are Quadra Hoses. They're really, this is a high pressure hose. This is your oil feed line. You can see here's my oil regulator. We got an OMC right here, so you can tell an OMC from an OMB. Quick thing is I got two sight glasses right here. Slightly bigger, high pressure, up to 1,800 pounds. I got my adapter. You're always going to see us putting in the proper adapter. This is a little more room to play with. This is a Quadra hose line. The Quadra hose line is a flexible hose line, and then it's a 3/8 line that's rated up to 10,000 PSI. Pretty impressive. This is what they use on the oil rigs.
Yeah.
This flexibility we like, because as a technician working in the field, if you get that compressor back in place and she's not exactly where she was, rigid design is a nightmare at that moment. So you got some flexibility. You guys put a little bit of loop in. So give or take a few, centimeters, you're good to go. Absolutely.
I love it. Yeah, no, that is so cool. And this is what's cool about the CO2 industry, is that we're coming up with different designs and newer designs than what was done before. And just little tips like that makes the life of a technician working on a system so much easier. And that's what it looks like you guys are trying to do.
We're trying to do as best as we can. It's we're listening a lot. We have a lot of great feedback from customers and technicians in the field. We're growing rapidly, so all this feedback people have from working on our machines only helps us improve the quality that we can deliver. Because the life of we give this type of machine is 25 years. So this machine, after it's gone, it's lived the warranty period. Someone else is going to live with it for another 24 years, right?
Yeah.
And we want to make sure the same type of things that we're talking about today, we're putting in place, it's going to be durable for the next 24 years for the technician on the site and the customer as well.
Yeah. So I love everything I've been seeing. We're going to go see a lot more stuff, and I really appreciate it. Phillip, how can more people get a hold of you, get a hold of these awesome CO2 designs to really get a better understanding for Arneg and what it's all about?
Well, we're always more than happy to quote a project, but if you want to tap into us, I mean, feel free to reach out to Trevor. We have a sales team throughout Canada. So Arneg, you just Google Arneg, go on our website. We all have a common email. You can shoot an email to us. It circulates through the family, and likely if you're looking for racks, it's going to come to myself or Jonathan.
Yeah.
We get a lot of inbox email. Specifically, tell us what you're looking for, and at date we can usually accommodate.
Yeah.
We're working on a new OEM manual that's dummy proof, as we call it. There's more pictures and writing. This is not a manual that's going to train you on CO2 engineering, but more like a format with pictures and how to. We did some research in the marketplace quite recently, and that was well received, and then my daughter is 6 years old, and she always is my training point as well. If she can understand what I'm asking, I've succeeded. So that's going to be coming out real soon, I would say mid to end of March. Awesome. It's a 16-page manual on how to take care of your Arneg machine.
Awesome. So head to the website, go check it out. Reach out to me if you want to learn more about Arneg Systems. As you can see, they're very open here. They want to help. Phillip sharing his extensive knowledge on CO2. Please reach out anytime, because we want you to have systems and working on systems that you can service easy, you can work on easy, you're happy, and build a relationship with a manufacturer who cares for the equipment you're working on. So awesome.
Hey,
awesome.
I think we should throw out the ILC.
Yeah, you go ahead.
So I'm going to throw out a plug to our friends at Copeland and Emerson. Quite soon there'll be an integrated learning center with an Arneg machine. They're really happy about this. It's going to give total visibility on CO2 design. We're designing in such a way that we'll be able to turn off the rack, we'll be able to vent gas is really a cool machine. We're doing it with a tankless boiler.
Nice.
So it's a hydronic load, so we can adjust superheats and do whatever is necessary that Emerson really wants to hit home and train with. So that's coming soon to Ontario, and I know Emerson is opening up their door. They want to train a handful of technicians continuously.
That is so great. That's exciting. I'm super excited because
we are too.
Very close to me. So I'm super excited about that. Make sure you check out Arneg's website, reach out, because this is game-changing stuff for the industry. And I'm so excited because you guys are doing CO2 medium temp, low temp, industrial, C-store, supermarket, air conditioning. I love it.
It's
CO2
starting.
is a good way, man. It's a good time to be in refrigeration. So catch us at the next CO2 Monday. Have a good one, everyone. Thank you so much.
Thanks for attending.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.